All right, everybody, here's take two on on actually recording the exam solutions. I'm going to try and do this kind of quick because I got stuff to do. All right, so A is this matrix, X is that matrix, B is that matrix, or vector vector. Write the matrix equation AX equals B as a system of linear equations, not as matrices. So as matrices, it would look like this: 1, 2, 0, 2, negative 1, 1 times the vector x1, x2, x3 equal to 2, 1. That's not the assignment. The assignment is to write the actual equations. So it's going to be 1 times x1 plus 2 times x2 plus 0 times x3 equal to 2, and 2 times x1 minus 1 times x2 plus 1 times x3. You don't really need those ones, but okay, equals 1. That's the system of equations. That's it. Also, as a reminder, you should definitely circle or box your answers. The person grading your work can see where it is. Find the product A times A transpose. So it's going to be A 1, 2, 0, 2, negative 1, 1 times A transpose. So the first row becomes the first column. The second row becomes the second column. We multiply it out. We get this times this. So that, or I should say this dotted with this. So 1 times 1 plus 2 times 2 is going to be 5. This dotted with this is 2 minus 2 plus 0. This with this is again 2 minus 2 plus 0. And then this row with this column is 2 plus 1 plus 1, which is 6. Cool. Let's find C inverse. So C inverse is going to be, and this is our matrix C. 1 over the determinant of C, which is 5 times 6 minus 0. And then we interchange the diagonals. And we change the signs of the off diagonals, but negative 0 is still 0. And normally I would just leave it like this, but I will point out that if you distribute this 1 over 30 to each of the terms, 6 divided by 1 over 30 is going to be 1/5. And 5 divided by 1 over 30 is going to be, sorry, not divided by, times 1 over 30. 6 times 1 over 30 is 1/5. 5 times 1 over 30 is 1/6. And it is not a coincidence that for this diagonal matrix, that C to the negative 1, or the inverse of C, each of the diagonal entries become their inverses. So that's 5 to the negative 1, that's 6 to the negative 1. We're going to see that pattern hold for any power of a diagonal matrix. I keep looking up there because that's what my camera is. Yeah, so that makes a little more sense to me. Sorry, one second, let me move things around just a little. It's weird for me to look at like the dot, look way over to the left there like that. Anyway, so for the next one, for C squared, we'll multiply it out. It'll be 5006 times 5006. We get 5 times 5 plus 0 times 0. We get 5 times 0 plus 0 times 6. We get 0 times 5 plus 6 times 0. And we get 0 times 0 plus 6 times 6. And not at all surprisingly, that's exactly 5 squared, 0, 0, 6 squared. And it is true that when you ever raise a diagonal matrix to any power, meaning diagonal is where the diagonal entries are possibly not 0, but every other non-diagonal entry is 0, then if you raise it to a power, you just get those diagonal entries raised to that power. So it is also true that C to the third power should be 5 cubed, 0, 0, 6 cubed. And C to the 100th power should be 5 to the 100th power, 0, 0, 6 to the 100th power. Easy. All right, for the next one, this next one's actually kind of, I feel like this next one maybe requires a little bit more room, but oh well, it is what it is. So we're going to solve this differential equation. It is a first order linear. So we're going to say that we have our P of X is equal to 2x, and our mu of X, I should say, it's already written in the standard way, right, where it's y prime plus a function of X times Y equal to a function of X. That's our P of X. That's our Q of X. Our mu of X is going to equal e to the integral of P of X, sorry, which is going to be e to the x squared. I think we should show all the work, but you might want to skip it. So the work is just that you're going to multiply the entire equation by this integrating factor, so that our new equation becomes e to the x squared times y prime plus e to the x squared times 2x times y equal to e to the x squared times x times e to the negative 2x squared. I'll point out here that the derivative of e to the x squared is e to the x squared times 2x. So this here really is the derivative of e to the x squared. So simplifying everything, The left-hand side, as usual, is a derivative of a product. It's the product e to the x squared times y. Took the derivative of that using the product rule, you'd exactly get the derivative of e to the x squared, which is e to the x squared times 2x times the not derivative of y, plus leave e to the x squared alone times the derivative of y. Equals, we're going to simplify this as well. We're going to get x times e to the x squared times e to the negative 2x squared. You add those powers, you get negative x squared. Integrate both sides. E to the x squared times y equals the integral of x e to the negative x squared dx. This integral is a u substitution. One second, let me move things around just a little bit here. Sorry. Limited room on my desk here. It's a little bit better. Okay, cool. So this integral is going to be a u substitution. This integral is a u substitution. We're going to let u equal negative x squared. Du is going to be negative 2x dx. Negative 1/2 du is equal to x dx. So this integral is going to become the integral of our x dx is negative 1/2 du, or e to the negative x squared is e to the u. We get negative 1/2 e to the u, which is negative 1/2 e to the negative x squared. Cool. So then our answer is going to be that e to the x squared times y is equal to negative 1/2 e to the negative x squared plus c. Right? Our integral, I'm going to throw in c. This is actually probably the easiest moment to find our constant c. Like you could divide both sides by e to the x squared, but it's just as easy to plug it in now. So plugging in, or actually, let me solve for y because I feel like it's a more normal way of doing it. So we solve for y. Y is equal to 1 over e to the x squared. That's your 1 over your integrating factor times your integral of mu of x times q of x, which ended up being negative 1/2 e to the negative x squared plus c. And then if you plug in y equal to 3/2 and x equal to 0, you get 1 over e to the 0 times negative 1/2 e to the 0, which is 1 plus c. So it looks like we have that 3/2 is equal to 1 times this, so it's negative 1/2 plus c. Add 1/2 to both sides, you get c equal to 4/2 or c equal to 2. And we plug that back into our solution. So our final solution is going to be that y as a function of x is equal to 1 over e to the x squared times negative 1/2 e to the negative x squared plus 2. You could also distribute that to each term. You don't really have to, though. I probably wouldn't unless someone said I needed to. Or if things kind of simplify nicely, but they don't really there. All right, move that cursor out of the way. Moving on. Find the equation of a sphere if one of its diameters has these endpoints, 2, 1, 4, and 4, 3, 10. So we've got a sphere, and it's some diameter, maybe this diameter right here. The endpoints are 4, 3, 10, and 2, 1, 4. We have to find the midpoint or center of the sphere. I should say the center of the sphere or the midpoint of that diameter. And the midpoint is just the average of the endpoint. So it's going to be the average of the x coordinates, 4 plus 2 over 2. The average of the y coordinates, 3 plus 1 over 2. The average of the z coordinates, 0 plus 4 over 2. That's moving around kind of weird. Which is going to give me a center of 6 over 2, 4 over 2, and I feel like I made, oh yeah, sorry, that's not a 4 plus 0. That Let me so let's see, it's a 4 plus 2 over 2, a 3 plus 1 over 2, and a 10 plus 4 over 2. Sorry about that. It should be a 14 over 2, which is 7. And then to find the radius, I would personally choose to find the radius as the distance between one of my endpoints and the center I just found. So the distance or the radius is going to equal the square root of 4 minus 3 squared plus 3 minus 2, or I should label this point 3, 2, 7. 3 minus 2 squared plus 10 minus 7 squared. That's going to end up equaling the square root of 1 plus 1 plus 9, which is the square root of 11. Then your equation of your sphere is going to be x minus the x coordinate squared plus y minus the y coordinate of the center squared plus z minus the z coordinate of the center squared equal to the radius squared. Don't write square root of 11 squared, write 11. Cool. A woman walks westward on the deck of a ship at a walking speed of 3 miles per hour. The ship is moving north at a speed of 22 miles per hour. So we've got a woman walking this way at 3 miles per hour westward, and a ship moving this way, which should be much larger, but my picture doesn't really look like it, at 22 miles per hour. And so basically, we want to find out, or the question says, find the speed of the wind relative to the surface of the water. We basically want to find out like how fast the person's moving. So like we're going to go this way and that way at the same time, right? Because while we're walking that way, although right not very far because the ship's not that big, we're going to be moving in this direction, right? We're moving north because the ship is moving north, and we're moving west because we're walking west. So we're just going to add these vectors together. I mean, well, sorry, I should say, we're not even really going to add the vectors together. Sorry, it's not really the right word here. Because they're not asking us to actually find the resulting vector. They're asking us to find the speed of the one relative to the surface of the water. So they're just asking us to find the length or magnitude of that vector. So this vector v, the magnitude of v is the square root of 22 squared plus 3 squared. I wouldn't simplify that really, but I will here. 22 squared is 484. 3 squared is 9. Add them together, you get the square root of 493. You should include the units of miles per hour. Assume that the population is divided into 4 age classes, and 50% of the females age 0, 40% of the females age 1, and 30% of the females age 2 survive until the end of the next breeding season. So that's like the ones that are going to, become age the next age. Those are the ones that are going to be below the main diagonal of our Leslie matrix. Assume further that females age 2 have an average of 6.2 female offspring, and females age 3 have an average of 1.8 female offspring. Those are going to be the things that go in the first row of our Leslie matrix. At time t equals 0, the population consists of this many females, 0, this many females age 1, this many females age 2, and this many females age 3. Find the Leslie matrix and the age distribution at time t equals 1. So to find the age distribution at time t equals 1, so that's going to be n0 of 1, apologies. No, that's right. N1 of 1, N2 of 1, and N3 of 1, which I like to call this N of 1. It's equal to our Leslie matrix, which we're going to find, times our N of 0, which they're telling us, oh yeah, the amounts at time 0 are 500 age 0, 300 age 1, 100 age 2, and 10 age 3. Right, so this is our N0 of 0, N1 of 0, N2 of 0, N3 of 0. So our Leslie matrix says 50% of age 0s make it to age 1. So we need a 0.5 right here. So the 0.5, is that right? I always feel like I'm doing this wrong. Yeah, right, because 50% of the age 0s are going to make it to the age 1 spot in our result, right? Because this times that is going to give me the thing that's in the second row here. And then we know that 40% of females age 1 are going to make it to age 2. So this 40% is going to multiply the age 1 folks, and it's going to end up in the age 2 row. And then finally, not finally, but and then 30% of age 2 folks are going to make it to age 3. So this 0.3 is going to multiply by the 100 age 2 folks to get to age 3. And then we have zeros, zeros, zeros. And then we also know that females age 2 have an average of 6.2 female offspring. So we need, right, this is 0, 1, 2. At the age 2ers, so this 6.2 is going to multiply by the age 2 folks right there to give us offspring in the age 0 row over here. And then similarly, we need a 1.8 over here so that we have 1.8 multiplying by the 10 age 3ers that are going to give us our offspring from the age 3 folks. And then zeros, zeros, zeros. So in a typical Leslie matrix, you have non-zero entries below the main diagonal and non-zero entries in some of the first row, but not necessarily all the first row. I'm thinking of, right, the columns are the column is how much the age 0 folks H1 folks, H2 folks, H3 folks contribute to the next year. And the rows are the age category that's getting contributed to. Doing the multiplication, let's see, we get 0 times that, 0 times that. 6.2 times 100 is 620, and 1.8 times 10 is 18, so you get 638, right? That's 620 plus 18. And then 0.5 times 500 is 250. 0.4 times 300 is 120, and 0.3 times 10 is 3. Okay. Find the age distribution at t equals 4. So basically multiply by L 4 times. So, and then you may represent your answer as the power of a matrix multiplied by another matrix vector. You do not need to multiply it out. So really what we're thinking is n of 4 equals L times n of 3, but n of 3 is equal to L times n of 2, and n of 2 is equal to L times n of, whoops, sorry, another L, apologies, times n of 1. Finally, n of 1 we just saw, n of 1 is equal to L times n of 0. So we can say this is equal to L to the 4th times n of 0. Which is how he writes his answers in the solutions. If you, and I probably would write it like that. You could write the whole matrix raised to the 4th power, which looks kind of silly, times this vector here. But as long as you've labeled things here well, like I definitely, if I hadn't labeled these here, it would be kind of bad form to do it this way. So definitely label these things, and then you can just write it like this, and you're totally fine. But definitely, if they're saying you can write something as a matrix to a power, you can just give that matrix a name like L and say, oh, it's that matrix name to the power times whatever vector is appropriate. Totally fine and preferred to do it that way. You don't want to spend more time writing than you have to on your exam. All right, a tank containing 50 gallons of salt water initially has a concentration of 2 pounds per gallon. Salt water with a concentration of 2 pounds per gallon is poured into the tank at a rate of 6 gallons per minute. And the well-mixed tank is drained at a rate of 4 gallons per minute. Set up a differential equation, emphasis on setup, for the rate of change of S of t, the amount of salt. So we're going to have ds dt equals the amount going in, which is the concentration going in, times the rate that it's going in at, minus the concentration going out, times the rate that it's going out at. Also indicate the initial condition, which is our S of 0. Do not solve the differential equation. Cool, we're just setting it up. So the only real issue for most of these problems is the concentration going out. So in this case, since the rate in, actually, we'll hold on a minute here. So the concentration going in is 2 pounds per gallon. The rate that's going in at is 6 gallons per minute. The rate that it's going out at is 4 gallons per minute. Since there's a difference there, the volume is changing. The volume is changing. It's going to be increasing by this rate minus that rate. So since that's a positive number, the volume is increasing by 2 gallons every minute. So your concentration out is always going to be your, just like your concentration in, it's the amount of salt per volume. It's the amount of salt per volume. In this case, the amount of salt is just S of t, right? We don't ever write in something for that. That's what the differential equation is trying to solve for. And your volume is going to be the initial volume of 50 gallons plus 2 times t, or 6 minus 4 times t. So that's what we have over here. S of t over 50 plus 2t. And then, even though I like writing, oh, and I always forget to write, this is pounds per gallon. And then we don't really like to actually write the differential equation with units, so then rewriting it so it looks kind of nicer. My lights just went out 1 second because I've covered up my sensor here. There we go. Okay. Sorry, I've got a time limit here. I've got 20 more minutes before I've got to go to office hours. I'm trying to wrap this up. So dsdt is going to be, let's see, 2 times 6 is 12. Over here we have 4 times s on top of this fraction divided by 50 plus 2t. And we know that S of 0 is the amount of salt times 0. Well, at time 0, S of 0 is going to equal 50 gallons of salt water times 2 pounds per gallon. which ends up being 100 pounds of salt. That's your initial condition. So there's our answer. All right, find the angle between the given vectors. Cool, I always like to write it as cosine of the angle equal to v dot w divided by the magnitude of v times the magnitude of w. In this case, v dot w is going to be 0 times -2 plus 1 times 0. What is the little dot there? That's interesting. I think because I drew it. Plus 2 times 4 over the magnitude of v, which is the square root of 0 squared plus 1 squared plus 2 squared, times the magnitude of w, which is the square root of -2 squared plus 0 squared plus 4 squared, which is 4 plus 16, which is 20. That ends up being 8 divided by the square root of 5 times 20, which is 8 over 10. So then my angle theta is the inverse cosine or arc cosine of 8 over 10. And that's as good as our answer gets here because we don't know what that is. If it was like the arc cosine of 1/2, so just as a note, if it ended up being the inverse cosine of 1/2 or 0.5, there is an expectation that you tell them that that angle is equal to pi over 3 or 60 degrees. Not really important here, but just I could see him asking a question that came out that way. Okay. Interesting. So cosine of this angle is equal to 0 times 5 plus a times b plus -b times a divided by the magnitude of x, which is the square root of 0 squared plus a squared plus -b squared is the same as b squared, times the square root of 5 squared plus b squared plus a squared. But I should have just paid attention to the top because 0 times 5 is 0, and a times b and -b times a, ab minus ab is 0. So you get cosine of theta equals 0. And then if cosine of theta is equal to 0, we know that theta is 90 degrees. Or if you prefer radians, pi over 2 radians. It's always worth just checking. If the dot product of the vectors is 0, you know the angle is going to be 90 degrees. So it's often like, especially with ones like this where you don't have numbers, I would really be like, is that dot product 0? Let's check it out. Okay, so to make sure I'm recording, I know I hit record, but I feel super paranoid now about it. Just let me check. I am recording. Okay, good. All right, so find the unit vector. There are multiple answers that are orthogonal to v equal to abc. Last time I did this, I gave like 6 answers. Here, I'll just do 2 of them. So you could have found one potential answer. Well, first, I'm just going to find some orthogonal vectors. I'll call it w. So w, one answer is switch a and b and make c equal to 0, but then change one of the signs. That vector is orthogonal, but it's not a unit vector yet. To make it a unit vector, you would then divide it by its own magnitude. So you take -b comma a comma 0 and divide it by the square root of -b squared plus a squared. It is equally good to write just b squared because -b times -b is the same as +b times +b. So that's one answer. Or another answer would be to find, say, let me call it something else. Now it's not. Or you could have done like switch, I don't know, a and c. And then change the signs of one of them. Let's change the sign of a. Then your unit vector would have been c comma 0 comma -a divided by the magnitude of that vector, which is the square root of c squared plus, I'm going to write a squared instead of -a squared this time. So whenever you're trying to find a vector orthogonal to another vector, especially if it's got 3 coordinates, you interchange 2 of the coordinates, change the sign of one of them, and make the third one you didn't use 0. If you check the dot product here, right, -b times a plus a times b plus 0 times c is -ab plus ab plus 0, which is 0. Same deal here. This dotted with that, c times a plus 0 times b plus -a times c is ac minus ac, which is 0. So that's usually how we find the orthogonal vectors. You switch 2 of the coordinates, change the sign of one of them, make the third one 0. Using the vectors from 6a, find the projection of w onto v. Cool. Projection of w onto v. That means v is going to show up all the times except for once. So I'm going to write it as w dot v over v dot v times the vector v. Or if you prefer, W dot V over the magnitude of V squared times the vector V. I prefer this. Either one's fine. So let's see. So W dotted with V, we already did that up here. It's 8. V dotted with itself. Oops, sorry, you can't see that. Apologies. Let me show you what I mean. So we already did W dotted with V. That's why it's kind of nice to refer back here, right? You don't want to repeat work if you've got a limited amount of time, especially. So W dot V is 8. And then V dotted with itself, well, we saw that the magnitude of V was 5. So the magnitude of V squared is going to be, sorry, the magnitude of V was the square root of 5. So the magnitude of V squared should be just 5. Or V dotted with itself is 0 times 0 plus 1 times 1 plus 2 times 2, which is 5. Times the vector V, which is 0, 1, 2. And I would just leave it like that. You can also distribute it and get 0, comma 8 over 5, comma 16 over 5. Either answer is totally fine. All right. Last page. A lot faster the second time. This problem, so I'll point out, in his solutions, he actually does this a different way than I have to do it, and he also makes a small mistake. So we'll address that at the end, depending on how much time we have. I'll just do my solutions first, and then I will talk about, I'll talk about how his answer is slightly different than mine, but in a way that doesn't actually matter. So here's how I would do this. First, separate it. So you've got y is on the left, x is on the right. And then my preference, instead of doing a u sub with a back sub, is to iterate x squared over 1 plus x to do polynomial division, because your degree on top is bigger than or equal to your degree on the bottom. So x squared plus 0x plus 0 divided by, I would prefer to write this as x plus 1 instead of 1 plus x. X is in the x squared x times. You multiply, you get x squared plus x. Subtract 0, negative x, bring down. X times negative 1 is negative x. Negative 1 times 1 is negative 1. Subtract. And then we rewrite this as 1 over y squared equal to the quotient, x minus 1, plus the remainder divided by the divisor. And then I forgot to leave room for my dy here, sorry. Then we integrate both sides. So integrating both sides, the integral of 1 over y squared is negative 1 over y, or it's the integral of y to the negative second, which is y to the negative 1 over negative 1, which is negative 1 over y. And then the integral of this right-hand side is x squared over 2 minus x plus the natural log of the absolute value of x plus 1 plus c. Okay, normally when I solve this, I like to, what do I like to do? Yeah, I like to multiply both sides by negative 1 personally. I'm going to not do that here, unlike what I did in the other solutions that I posted, so that my answer will look more like how his answer looks, and we can kind of see the discrepancy between our answers more easily. So what I'm going to do is I'm going to, sorry, the way he does it always feels weird to me. I guess I'm going to just, yeah, sorry, this never works in my brain the way it works in. Okay, I see. So I'm going to think of this as negative 1 over y. So negative 1 over y equal to all this stuff. I'm going to multiply both sides by y. So negative 1 equal to all that stuff times y. And I'm going to divide both sides by all that stuff. So I'm going to get y equal to negative 1 divided by all that stuff. X squared over 2 minus x plus natural log of x plus 1 plus c. I guess I can fill that. So I don't think you need to write this all in here, but I'm going to write it in. And that's definitely how he writes his answer. He just kind of does the reciprocal of both sides and moves the negative 1 to the other side. Right, so he gets, so what he kind of, the step he probably takes, he probably says like y over negative 1 equals 1 over all this stuff. And then he brings the negative 1 up over, multiplies the sides by negative 1. I usually have my negative distributed in the bottom instead. Either way is fine. Yeah, I think I have enough time to talk about this here. So I'll point out his answer looks a little bit different when he does this integration here. Instead of doing this division, what he decides to do instead is a u sub with a back sub, which kind of takes a bit of time. I think my way is actually faster. What he does is he says, cool, I'm going to let u equal 1 plus x, du is dx, and then my integral of x squared over 1 plus x becomes the integral of something over u, du, and then x squared is going to be, well, x is u minus 1, So x squared is u minus 1 squared. If you multiply that out, you get the integral of u squared minus 2u plus 1 all over u. And then if you divide, you get the integral of u minus 2 plus 1 over u. You integrate that, you get u squared over 2 minus 2u plus natural log of the absolute value of u plus c. Then you rewrite back the x, you get x, I'm going to write x plus 1 instead of 1 plus x plus 1 squared over 2 minus 2 times x plus 1. And right here, he loses the minus sign. He accidentally writes a plus 2 instead of a minus 2 in the solutions. So we're correcting that as well. Plus natural log of absolute value of x plus 1 plus c. Now, his final answer is -1 over all of this, which looks a little different than my final answer. Here's where we're getting a difference. Our constants are actually slightly different. Well, mine's C1, I'm going to call his C2. Here's where that difference is coming into play. So if I multiply this out, x plus 1 squared is x squared plus 2x plus 1 all over 2 minus 2x minus 2 plus natural log of x plus 1 plus my C2. Simplifying this to make it look like that, x squared over 2. 2x over 2 is x minus 2x is a minus x, looking good so far. And finally, I've got a plus 1/2 and a minus 2, which is a minus 3/2 plus natural log of x plus 1 plus C2. And here's where my answer looks a little bit different. I don't have this minus 3/2, but essentially my C1 is equal to his C2 plus the minus 3/2. Either way of doing it is fine. His answer should have looked like -1 over x plus 1 squared minus 2 times x plus 1 plus natural log of x plus 1 plus C2. But if you look at his answer, and I think I have it up here 1 second. Yeah, let me share this. Sorry. Let me share. So if you look at his answer, you can see the work he did that we just talked through of doing the integration by, make sure I'm sharing the right thing here. Sorry. Okay, I am. Yeah. Cool. Right, he did the u substitution with the back sub. And then when you multiply it out, right, you have the 1/2 u squared minus 2u plus natural log of u, absolute value of u. But then when he plugs in u equal to x plus 1, this minus 2 right here accidentally changes into a positive 2. So his answer doesn't look quite like mine because this is a little bit wrong. My answer written his way, I didn't find it. I wrote the denominator. So right, the part I have is the 1/2 1 plus x squared minus 2 times 1 plus x plus natural log of absolute value of 1 plus x plus c. And then we write -1 over, and that'd be the final answer. Either way is fine. I do think my way is better. One, because it produces a nicer answer, and also two, because it's faster to do it my way. U sub with a back sub is usually slower than doing polynomial division. So if you have some power of x divided specifically by a linear thing like x plus 2 or x plus 1 or x minus 3, you can do U sub with a back sub, but it's faster typically to do polynomial division. All right, last problem. My extra credit problem didn't include one of the things he had on his extra credit problem because it was a pain to write. So first question here, find C23, the entry of C in the second row and third column of the product of A times B. So C23 is equal to the second row of A dotted with the third column of B. Right? If you're doing the multiplication, first row, first column gives you the 1, 1 entry. First row, second column gives you the 1, 2 entry. If I want the 2, 3 entry in the second row and third column, I'm going to do the second row dotted with the third column. That's going to equal second row, 2, 3, 4, 1, dotted with third column, 1, -2, 3, -5, to get 2 times 1. I do think for these dot products, it might be worth writing it out if you have the time, so that in case you make a small error, they can see that you still knew what you were doing. Plus 3 times -2, plus 4 times 3, plus 1 times -5. That's going to be 2 minus 6 plus 12 minus 5. -6 minus 5 is -11, plus 12 is 1, plus 2 is 3. Another thing I'll point out, and I always say this, I'll say it again, make sure you read the questions carefully so that you know what you're being asked to do and you're not doing more work than you need to, but you're answering the question as appropriate. Always read the questions slowly, thoughtfully, carefully. It is not the time to speed through the test. Reading the questions is the time where you go slow so that you can do the other things at the pace you want to go at. Okay, third row of C transpose is equal to the third column of C, which is definitely the way I would think of it. So the third column of C is going to be, well, we know that the entry in the second row and third column is the second row of A dotted with the third column of B. So if we want all the entries in the third column of B, we need to do the various rows of A dotted with the third column of B. So to find the third column of C, so column 3 of C, my notation here is not standard. I'm just making it up really. It's going to equal row 1 of A dotted with column 3 of B, and then that's going to, the next entry is going to be row 2 of A dotted with column 3 of B, and then it's going to be row 3 of A dotted with column 3 of B. Notably, A is a 3 by 4, B is a 4 by 3. When you multiply it all out, you're going to get a 3 by 3 matrix, so the third column should have 3 entries. Here, I'm not going to write out my work because I'm almost out of time. So row 1 of A is going to be that dotted with column 3 of B, so it's going to be 1 plus, I'll write 1 plus -4 plus 3 times 3 is 9, plus 4 times -5 is -20. We already know what the next entry should be. It's going to be 3 from the work we did right there. And right, don't repeat work you've already done. That's why often questions get asked in a way so that you don't have to. Finally, row 3 dotted with column 3 is going to be 3 times 1, 4 times -2, 1 times 3, and 2 times -5. So then I would get, let's see here, -3 plus 9 is 6, minus 20 is -14, 3 minus 8 is -5, plus 3, and let's see, -18 plus 6 is -12. I feel like the answer is different than the one I got before. Let me double check real quick if they do have to get out of here. Nope, that's right. Okay, cool. And so I'll just point out, so I would then maybe relabel it as the third row of C transpose and write it as a row is -14, 3, -12. I don't think it really matters that much, but you know, whatever. All right, that is the solutions to the practice exam. I'll post these as well, even though they're pretty much the same as the ones I wrote already. I feel like these look a little bit nicer. And also this is the updated version of the test without any errors on it. So good luck on your exam on Monday, and I will see you all on Tuesday. Bye.